Welcome to the VI Technology booth here at Nepcon Shanghai. I'm delighted to be joined by Jean-Marc Peallat, who's the Global Sales Manager, or Director, should I say.
Thanks for stopping by.
Okay. Good to see you, Jean-Marc. A couple of things I want to talk about today. You brought out the Pi SPI system about 3 years ago, which is quite a revolutionary product. You've recently brought out another 3D AOI system. Can you tell us how these systems work and how they integrate?
Okay, so we have been in the AOI business for 20 years now, and we introduced this year our 3D AOI, which is based on our solid platform from 2D, and we just add a module on this platform. It's a 100% 3D AOI with 2D also capabilities. So we use a laser-based solution, which gives us the ability to measure small components close to the board, like O2, O1, but also tall components in the same time,
right,
which is very typical of automotive industry, for example.
Yeah, okay. So automotive does have a lot of bigger components. What sort of maximum Z height do you go to on that?
25 millimeters.
Okay, that's perfect. Okay, so you have the 3D and 2D built into this machine, but they operate at the moment in separate paths. If you do,
it's a two different paths, but we are compatible with the cycle time of the lines of our customers.
Okay.
But it's important to get a true telecentric lens for the 2D, which gives you a very good images for the 2D, but also good images for the 3D reconstruction.
Right.
And but what is the best innovation here? It's our new software.
Yeah.
We call it Sigma. So here you have the Sigma Review, which combines both results from SPI and AOI 3D. And so it's the opportunity to compare measurement from the SPI and measurement post-reflow. And this is a good tool to optimize your process tolerances of the SPI. We know that 70% of the defects are coming from the printer.
Yes.
But most of the time, our customers are using the SPI as a tool to measure roughly what is happening. So with this tool, it's the opportunity to reduce the tolerance and catch more defect at the SPI.
Right. So they're using the SPI to harness some metrology to measure for defect, for offsets and this type of thing. But you can also see 3D, of course, with the SPI.
Yes.
So why do we need both?
You need both because we need both technology because we don't measure the same thing, right?
Right.
Volume is very important for small components, and when the pad gets smaller, volume is key because especially on the 01, 05, these small components are just floating.
Yeah.
Okay, and with the component inspection, you also measure the complementarity of the component. If there is a small component under a BGA, you are able to see it, for example.
Okay.
So that's something you cannot see on the SPI.
On the SPI, okay. So they're doing two different things.
Yes,
and,
we are measuring two different steps of the process. And today the trend is also to get SPI, of course, after the printer, AOI 3D after the pick and place, and AOI 3D after the reflow. So you have all steps are on control, I would say.
Okay. But at the moment, most people really have their inspection after reflow, post-reflow. But you think it's becoming more and more important to have that post-placement check?
Yes, because if you want to prevent defect, you have to measure your placement. Otherwise, you just collect and catch the defect at the end. So if you want to control your process, you have to control where it happens. Sorry, and also it's cost effective to repair if you have to do some repair before the reflow.
So just to be clear, the SPI system is now communicating with the 3D system here.
Yes.
The 3D system is communicating with the pick and place, and the SPI is also communicating with the pick and place.
We developed what we call closed loop with the printer, closed loop with pick and place.
Yeah.
But what is very important here is to get the both inspection system to communicate together.
Right.
We have a direct link between the system, and it's a way to improve your tolerances on the SPI and narrow your tolerances to catch more defect.
Right. Well, that makes a lot of sense. So, I want to thank you very much for giving us a walk through the new system, and I wish you the best of luck with it.
Thank you.
Thank you.